Hi everyone, and welcome to the first webinar of it will be an introduction that how we can integrate blockchain with the FIWARE technology. Here I'll be covering how we can integrate blockchain with the FIWARE ecosystem and utilize the component that which we can leverage in a FIWARE ecosystem to persist the data. Before I start, let me introduce myself. My name is Preet, and I'm a technical expert and evangelist in a FIWARE Foundation. And I'm also a certified blockchain solution architect. And so let's start. And before we go further, we just need to, just tell that we all witnessing and we are approaching to the new digital revolution of data, where more than a half of the world is connected to the internet and generating a massive amount of data. And almost everything is connected to the internet using IoT, which require a new generation of a context-aware smart application. And this new digital life will gravitate around the context information. And if we talk about the context information, it's like what's going on, where, when, and why. And as the number of devices and the data is growing, that can create a data silos because many devices may use a different standard. And it will also create a difficulties in achieving interoperability. So here we can leverage the FIWARE technology to solve this problem in our smart solution. And about FIWARE, it's an open source platform and component to access and manage your heterogeneous context information through open APIs. And the way this works, it's provide a standard to manage your context information. It's called NGSI. And there are many generic enablers and solution to make your service better. And it work is a manner of a building blocks that if you have some component that you can plug in and plug out as per your need example, that if you have some IoT device to connect with the context proper, you can use any agent, and which will give you a way to communicate with the device to the data in a standard manner. If you look at the catalog, there are various globally adopted standards exist and various generic enablers you may find here, which you can use to design your smart solution. Now, here I'm here to talk about the blockchain, so let's go further. And you might have heard that everyone is talking about the blockchain and various organizations and companies already using it. But the question is, why blockchain? To understand it better, we'll have a brief overview about the blockchain first. And the blockchain and distributed technology, it's first became in a globally known way. It's when the Bitcoin is arrived. It's a first cryptocurrency and also the first ever blockchain implementation. It's also known as the next generation internet or decentralized web, you can say. And the main goal behind this technology is that it will be shared, trusted, could be a public and private ledger of transaction. There shouldn't be any controlled party. It's distributed, and there won't be any delete operation, so that data won't get tampered. And to make your data secure, it utilizes the cryptography. And the main motivation behind this blockchain is to solve the age-old human problem of trust. So if you have any trust issues between the organizations, or you wanted to make more transparency, then blockchain could be a good solution. And how this blockchain has been totally evolved, and I'm expecting that we already living into a distributed world, and now moving towards a decentralized. The main goal behind this blockchain to overcome this cap problem. This cap, where C stands for a consistency, that read are always up to date, which means that any client which making a request to the database and get the same data or the same view of the data. And about the availability, database request should always respond when it is valid. And in a distributed itself, it's a partition tolerance, but to achieving all these three together, it's not possible in a distributed way. But here, the first implementation of Bitcoin is try to solve this problem by proposing a consensus. So there are various consensus algorithm also exist, and the main goal behind this algorithm to achieve the reliability in the network involving multiple distributed node and containing the same information. Now, why it is called a blockchain. So this ledger is built using a linked list or a chain of blocks, where each block contains a certain number of transactions that were validated by the network on a given timestamp. And the crypto economy rule sets of the blockchain protocol regulate the behavior of rule set. Example, when the consensus perform and you are one of the miner on the network, you get rewarded. And now, the way that blockchain work, example that if Alice wanted to send some money to Bob, so it will create a transaction, and that transaction is represented as in a block, and it gets broadcast to all the parties involved in the network. Network validate the transaction, approve if valid, and there is a consensus algorithm may play a role. Example that Bitcoin uses proof of work, and Ethereum uses currently using a proof of work, but now moving towards a proof of stake. And now after it gets validated, the block can be added to the chain in a mutable and a transparent record, and the money is moved to the Bob from the Alice. There are different kind of blockchain exist. So if we talk about the public and private, we can determine in a term called who can write the data on a blockchain. And this publicly available blockchain means that everyone can add the record, and a private, only a certain participant can write data on that. Here you can, there are many private blockchain like such as Hyperledger Umbrella that have a permissioning, and you can implement your own rule sets to make private data. And the other combination could be the open versus closed, where the read operation can be open for everyone. You can, if it's an open blockchain, then everyone can read the blockchain data. If it's a closed one, that only a certain participants can read the data. Now here, there's also a term which may distract everyone. It's called a DLT and blockchain. Yes, DLT stands for Distributed Ledger Technologies, and there are all the blocks which are DLTs, but all the blockchain is not. All the DLTs are not a blockchain. Example, if you might have heard about IOTA Tangle, so IOTA Follow, concept of directed acyclic graph. It's a DLT, but it's not a blockchain. And to define the use case, that which blockchain should we use for which application. So here I've tried to show you a small matrix example that if you are building some cryptocurrency or a betting, then you opt for a public and an open blockchain. Example, if you are trying to build some kind of a supply chain or a financial record service where you need a permissioning and some participants to control and validate the data, you should go with the private and open blockchain. Now, the next point, that how FIWARE and DLT complements each other. So here in a FIWARE, when we create or update any context information, itself is a transaction. And immuting this transaction by storing into some kind of DLT can provide transparency and traceability, and somehow you will also try to achieve a provenance by applying some kind of provenance model over it. And there could be a possibility that we don't need to store all the information in a blockchain, and we can filter it out what information we need to store, especially when we're designing a private blockchains. And blockchain also lacks in a standard because it's a quite new technology and there are not many standard exist yet. So here we can leverage this NGSI in a DLT, and it will also help us to achieve the interoperability in case if we wanted to move from one system to another one. So in the combination with the blockchain and a FIWARE, it will result a more security, trust, transparency, and traceability, interoperability can be achieved. This traceability and transparency, we can achieve using the immutable nature of blockchain technologies, and the interoperability using standard behind the blockchain, behind the FIWARE. Now to demonstrate, I've prepared a small demo. It's for the agri-food supply chain. Let's take an example here that there are a few parties. Example that this FF farm is a food producer who is responsible to grow and harvest and the crop a wheat, and then it shipping this grown wheat to a company called a Biopasta. He's a manufacturer and he's responsible to turn this wheat into a flour and make a pasta. And after the packaging, it again shipping it to the railway or some retail store that you have. Then, and from here, if some consumer like a Mr. Jason has come in and buying this pasta, and he always have a trust issue to check this pasta is good enough and from where it came from, and is always interested in looking into all this detail. So here we can design the system we have a context broker at the center, that where the data is coming up in a standard manner, and your database is Mongo is connected with the context broker, and you can connect your DLT services and make a subscriptions that what kind of data you wanted to persist, and the services can get connected to a specific network. And for the demo, I've created one service for the IOTA and one for the Ethereum clients. And this client, you can either use a Ethereum network or maybe Morgan Chase Quorum or Hyperledger Besu. So they all have somehow the same RPC protocol. And there could be a different possibility, but here I'm demonstrating you two of them. You can always go to this link and download the source code and play around. Let's try to check. Okay, so in this URL, you can go and clone this repository. There are some descriptions and the details available that how you can utilize it. Let's start with the demo. And when you come here, clone the repository, you will find one IOTA service and Ethereum. Let's start with the IOTA. I'll come to this Docker Compose, and you will find here it's using a context broker and connected to your database. And one service which I created, it's called IOTA service. It's getting built from this particular source code. And to connect to the particular network, I'm utilizing IOTA dev networks. You can go on their document and find which kind of nodes are available. Maybe if you wanted to build a local one, you can mention it here. Let's boot this up, and I'll go to the IOTA folder. I'll make sure there shouldn't be any container running here. I go and make this up. Now I can see here this 3 services is being created. To verify, I go and check. So the context broker is listening on a 1026 and the IOTA service is running on 3001. Perfect. And there's also Postman collection exists here. You can import this API in your Postman. So when you import, you will find this 4 folders, which has a basic operation that which are getting performed here in this demo. I simply go on IOTA and try to check either it's working or not. So yes, I can see here the network is up and working. And there's also a front-end app exists. I simply go to this agree food application and make sure the configuration is correct. Currently, I'm presenting you this IOTA type. I'll start the application, and the moment it's booting up, I'll go on a Postman and create a one subscription. And the subscription is when I'm creating a new kind of entity called agri-food, it's going to update these context, going to notify this context on my IOTA service, and this IOTA service will further persist the data in a blockchain in a IOTA DLT. I'm going to create this subscription, and it's been successful. Now let's come here. You can see here the app is running. I will try to open it, and I'll enable my CORS to get it running in a local host. Okay, now here I have created 3 accounts for the demo purposes. So there is a one party exists called FF Farm, and another one is Bio Pasta, and the third organization, which is Rebe. So here the account and the private key for the specific organization exists here. Now, if I come to the FF Farm in a farm producer area, I'll go and try to create one asset. I created, it's generating one entity ID of agri-food type, and I'm naming it, it's a hot grain wheat, and I will mention it's a well-refined hot grain wheat. And there we can also mention here, and if any type of parent or a child exists for this entity, this product, but here I will say that there isn't. And now I'll go and try to create. So when you see the entity is created, but there isn't any transaction exist yet, because at the background, the transaction is getting mined. And if we try to log my service, oops, sorry. Now I can see, yes, the transaction has been created. And when we try to refresh this from producer, now we can see that this entity has been persist in a IOTA tangle, and this is your transaction hash, and this address is being used to create this asset. Now this farm is shipping this wheat into the Bio Pasta manufacturing company, where they will be responsible to create a pasta. I'll come to the Bio Pasta area, and here I'm trying to create an asset, which I'll say it's a penne pasta, and I mentioned penne pasta and of maybe 500 grams. And I can choose here which the parent that I've used. I simply go and choose that I'm using FF Farm, the hot grain wheat which they have shipped to us, and this pasta is being made using this wheat. So I'll save it, and again this is getting mined, and if we try to refresh, I can see the transaction is created from this particular address, and here this address belongs to this pasta company. And I go to this Rebe distribution. From here, this pasta shipped to the Rebe distribution, and Jason Foxes came in and tried to buy it. Before buy, he wanted to check that how this pasta has been made. He will go and click on the view traces, and when I click on it, then I see that this pasta is being already persisted on this particular transaction hash, and it's been created by this parent, and this parent is basically FF Farm, who is responsible to harvest this hot grain wheat. And so further that you can create a complete traceability, and you can also add the transportation that using a GS1 standard and make it persist in your DLT. Great. So this is how you can utilize IOTA in context broker to persist your data. Now, another demo which I'll be showing you using Ethereum, I'll simply go here and make this container down. I will remove all this container and make sure there isn't any container existed. So I go back and go to the Ethereum. And before that, let me show you the Ethereum Docker Compose file. Here, this is also the same. We have a context broker connected to the DB, and there's a one Ethereum service. And here I'm using Ganache CLI. It's a test RPC network. You can use any RPC network that you want. Either it could be your ROPSNet or any proof of authority node or Hyperledger Besu. But here, for the testing purposes, I'm using Ganache CLI. And I'll go here and make this Docker Compose up. It will create the containers. And now the Ganache also have a feature that will give me a few demo accounts with the public and private key. And I'm using this top 3 account and distributing it to various part. Example, this account is I'm assigning to FF Farm, and this one's to BioPasta, and this one for the Revit. And now when it gets bootstrapped, you can also see there is a one transaction occurred. So to see here, we'll come to the Ethereum service, and there is a one contract exist. We'll see the contract here. This contract is responsible to persist your assets. And this assets have a struct which have few variables like a name, descriptions, who has the parent and who is the owner. And there's a one method exists called add asset. And at the end, it will adding all the assets in one array. You can design your own contract and use it in your application the way that you want. I've also included a one event emitter. You can read this event by creating some service and make this data again available in a context broker utilize the context broker as an off-chain DB. So we will discuss about this later in this session. Cool. So when we bootstrap this application, the app is deploying this contract, and here you will see the transaction is being occurred and it's being deployed in a block number 1, and you will find the contract address here. Okay, let's come to the app and see in the UI. I will go to this agri-food app and change the configuration to Ethereum, and I will refresh it. Let's come back to the front end, and when we come back here, now you'll see that the DLT type is Ethereum. And as I mentioned you, these 3 accounts that I'm using, which is being generated from this test RPC network. You can always verify here. Now again, here I'll go on the farm producers area, which is FF Farm, and I'll try to create a one asset. I'll name the same, blah, 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 and yeah, and when I try to create, we can go and inspect. There is a one transaction is being mined. We can always go here and maybe try to check the log on this container. Maybe it's better to log on the CLI and see the transaction hash over here. Okay, there isn't. It's because that we haven't initiated the subscription. And when we initiate the subscription, then the context broker will update this context of agri-food type here. Now let me enable the subscription, and as soon as I enable, I'm expecting that there should be one new transaction has been triggered. It's on a block 2, and the entity is being updated on created on a blockchain, and this particular transaction is being used. So now when we come to the app and try to refresh it, here it's great. So we can see the transaction is being created and this particular address being used. Again, we'll come to the bio pasta company. We try to create a penny pasta. It's a penny pasta of 500 grams, and this pasta is being created and processed using the wheat that which FF Farm has been produced. And I'll create a new pasta here, and we'll try to investigate. Again, we'll see there is another transaction exists on a block number 3, which has this transaction ID. And I'll try to refresh the UI, then I can see the transaction is being added. And this particular address is used to create the transaction. And they are again shipping this penny pasta to the retailer like a Reve. We'll come here before buying. I can go on a traces and try to find who are the owner behind this and what transaction. You can, if you have some maybe proof of authority node or any Hyperledger base, so you can connect your CLI with the blockchain explorer, and people can investigate and see an explorer that how this transaction has been created, what the contract address being used, and what details the contract has been used. Great. So this is how you can utilize your DLTs and Ethereum, different kind of blockchain using context broker to process the data. So here I've given you a small demo how we can leverage IOTA and Ethereum, but there could be a number of possibilities that we can use maybe Hyperledger Fabric network and create a chain code and connect with a service, and maybe Hyperledger Sawtooth, which I'm planning to give a small demo in a next webinar. So there are various components that we are trying to build to connect with the FIWARE. One of the component I will say it's a canis major. It's an adapter which will help you to deploy to persist your data in a blockchain without any human intervention. You can simply make a config subscription with the canis major and mention few of your configurations like your ABIs and the variables that you wanted to persist, and you can use a separate key manager to manage your keys, or maybe some front end like a MetaMask to sign your application. And the current this component will only be working with the private and permission or permissionless blockchain. This development track is not for a public blockchain, and it's not going to help you with the token or ICOs and cryptocurrency, but yes, it will work for private and permissionless blockchain. And there are a few more components which we are developing here. It's one of the components. It's Ledger Sync. It's responsible to listen all kind of events which we have in a blockchain, and you can connect with the FIWARE historical component, and you can utilize FIWARE as an off-chain storage. And another development track is Decentralized Context Broker. So using a Tendermint, BFTs, and Cosmos network, we can create a context broker in a decentralized manner, where there won't be any CRUD operation, but block creating and a procedure will be same, and the BFT algorithm will be used on a background as a consensus. And another component it's also under consideration is a key manager. It's very difficult to manage your public-private keys and blockchain or DLT keys. So using this component, you can manage your keys. Now here, this adapter, which I just mentioned, is will help you to submit the data directly to the blockchain. It will work on a unidirectional way. So it means that you just create a subscription and mention some detail. It will persist the data. It's been developed by the FIWARE Foundation and Federal University of Rio Grande do Norte in Brazil. So they are we are developing this adapter. And just to give you an overview. So for example, in adapter, there will be one YML available. You can mention the configurations like variables which you wanted to persist from the context broker. Mention the configurations such as which blockchain that you are utilizing. You can mention account details, but in the future you can use any key manager, or maybe if you have your own key manager like MetaMask or different managers, then you can utilize those as well. And especially in JSON RPC network, you create a contract. You can mention your ABIs here after compiling. And we are planning to release a basic version in July 2020. It's supposed to release in June, but somehow it got delayed because of some testing and some internal process. And initially, it will be supporting Ethereum, Quorum, IOTA DAG, and Hyperledger Besu. And the further development will go to support these blockchain. And about the ledger sync, there are some event listener which is getting implemented on this component. Example that Sawtooth utilizes 0MQ, and for the Ethereum there are some Web3 events, and RPC PubSub. Whenever these events get created on your blockchain, you can simply mention this configuration, like which kind of blockchain that you are utilizing, and you will be able to see the log, the event, and after that, from there you can filter it out which event you should persist into a historical data component, and you can connect some UI like a via Cloud Grafana to visualize or maybe make some more decisions. And we are planning to release this into October. It will also a very basic version for now, and we are writing in a Golang to achieve more concurrency. And as I mentioned, there are these two more research track which is currently ongoing research, and we always welcome the contributors who have some ideas and wanted to develop components in a FIWARE ecosystem. Feel free to drop us an email and share your ideas and contribute to the community. So this is it from my end, and if you have any questions, then feel free to ask me.